Hi viewers and students, this is the topic of two-way ANOVA in testing of hypothesis in research methodology and statistics. Now we'll look at how to solve a two-way ANOVA problem. Set up an analysis of variance table for the following two-way design results. So here this is the data concerning the per acre production when we use different varieties of seeds and different varieties of fertilizers. So here WXYZ are fertilizers, ABC are different varieties of seeds. So when we use the fertilizer W and the variety of seed A, the yield is 6. Like this data goes on. So in two-way ANOVA, here the question is there any significant difference in the yield when we use different varieties of seeds and fertilizers? That is what we are going to test using two-way ANOVA table. So in the first step, obtain the total values of individuals. Total is equal to sum of all individuals. So sum of all these numbers. So it is 60. It is represented with T. T is 60 and N equal to 12. N is number of entries here. And in step 2, we will calculate the correction factor CF. So correction factor is T square by N. So T is 60. 60 square by N is 12. It is 300. Now in step 3, in this step, we will calculate total SS. Here SS means sum of the squares. So total SS formula is square of all the item values minus correction factor. So here we will square all the values. 6 square, 7 square, 3 square, 8 square and square of all these values. So 6 square is 36, 5 square is 25, 5 square is 25. Like that, square of all the values. It is 332 minus correction factor is 300. So it is 32. So total SS is equal to 32. Now in this step, we will find SS between columns and SS between rows. So SS between columns is sum of the squares of individual columns minus correction factor. So sum of the squares of individual columns. So sum of this column is 24. Sum of the second column is 20. Sum of the third column is 16. So square the sum divided by number of sample size 4. So 20 square by 4 plus 16 square by 4 minus correction factor 300. So it is 144 plus 100 minus 60 minus 300 is 8. Now we will calculate SS between rows. SS between rows is sum of the all squares of individual rows and divided by number of sample minus correction factor. So sum of all the individual rows. So the first row addition is 16. 5 plus 5 plus 6. 16 whole square by how many samples we have? 3 samples. 3 plus this is also 16 square by 3. Third sample, third row total is 9. 9 square by 3 minus 300. So it is 18. Now SS residual or error. SS residual formula is total SS minus SS between the columns plus SS between the rows. So total SS is what? 32 and SS between the columns 8. SS within the between the rows 18. So 32 minus 8 plus 18 is 6. Now we will find out degree of freedoms. So degree of freedom for variance between the columns. Formula is C minus 1. C stands for columns. So in this problem we have 3 columns. We have 3 columns 1, 2, 3. So 3 minus 1 is 2. Degree of freedom for variance between the rows is equal to r minus 1. So this is equal to, we have 4 rows, 4 minus 1 is 3. Degree of freedom for residual variance is c minus 1 into r minus 1. This is 2 into c minus 1 2, r minus 1 3, which is 6. Degree of freedom for total variance is c into r minus 1. This is 11. Now we will put all the results in the form of a table. SS between the columns. SS between the columns is 8. SS between the rows is 18. SS residual 6. Degree of freedom for columns 2. DF for rows 3. DF for residual variance 6. DF for total variance is 11. Now we will set up the null hypothesis. Before doing this process also we can set up the null hypothesis H01 or H1. There is no differences in the sample means with variety of seeds, and there is no differences in the sample means with different fertilizers. These are the two hypotheses. Now we will set up the two-way ANOVA table. So this is two-way ANOVA table. First, sample of variation, sum of squares, degree of freedom, mean squares, F ratio, and standard values, table values of F. Now here between the column treatment, between the row treatment, residual or error, total. So sum of the squares between the columns, SS between the columns is 8. Sum of the squares between the rows, SS between the rows is 18. Residual is 6. The total is 32. Now degree of freedom between the columns. Degree of freedom between the columns 2. Degree of freedom between the rows 3. And residual is 6. It is 11. Now mean squares. 8 by 2 is 4. 18 by 3 is 6. 6 by 6 is 1. Now F ratio 4 by 1. 4, 6 by 1, 6. So between the columns and between the rows. Columns means variety of seeds. Between the rows is variety of fertilizers. So F value for 2 and 6 is 5.14. 2 and 6. And F value for 3 and 6. 2 and 6. 3 and 6 is 4.76. These are the calculated values and these are tabular values. So now we will compare calculated values and tabular values. Here 4 and it is 5.14. 4 is less than 5.14. 6 is greater than 4.76. So our conclusion is F calculated value between the columns is 4. F tabulated value for the columns is 5.14. That means F calculated value is less than F tabulated value. So in this case accept H01. What is the meaning of that? The difference concerning the variety of seeds is not significant, that is insignificant. In the second case, F calculated value is 6, tabulated value is 4.76. F calculated value is greater than F tabulated value. So reject H02. That means the differences concerning the variety of fertilizers is significant. That means there is a difference in the yield of the crop. This is two-way ANOVA.